Good morning, everyone. So today we're going to learn about gravimetric analysis, and this chapter is part of application in analytical chemistry. Starting from chapter 6 until chapter 10, it will involve lots of application part, and I hope that you can do your best to understand very well for chapter 1 until chapter 5. So here is the chapter description and what we expect that you will get after you learn this subtopic. Okay, so here is the expected outcomes. Okay, you'll be able to understand and state the principles of gravimetric analysis. You also will be able to describe the gravimetric analysis involving precipitation reactions. And the third one is to state the requirements to remove potentially interfering species prior to the gravimetric measurement. When we talk about precipitation reaction, we are talking about the formation of a precipitate after mixture of chemicals occurred. Here is the contents for this topic. Okay, the first one you will be able to learn the steps in gravimetric analysis. Next is the precipitation agent. So as you all know that any kinds of chemical reaction that will produce precipitate uh, will need or will require precipitation agents. Okay, so next is the mechanism of precipitation. You will learn how they can how the precipitate will be formed. Next is the impurities of particles. Okay, so by the time the precipitate form, actually they will contribute also or invite the impurities, okay, that will agglomerate with the precipitate. Okay, next is ways to overcome the impurities problem. Okay, so you will also learn on how to minimize the impurities, okay, to avoid any impurities, okay, in your precipitation. Next is a gravimetric calculation. Okay, so basically this chapter also involved with the calculation, and the last part is the volatilization and particulate gravimetry. Okay. Okay, what is the definition of gravimetric analysis? Okay, it's a quantitative determination of the amount of analyte through a precipitation process. Okay, it means that you try to isolate the precipitate from the solution and to determine the isolated product weight. It's a kind of analytical methods that measure the mass or mass changes. Okay, when we talk about mass changes, it means that how much is the mass reduced or how much is the mass added. Okay, so that is the changes that we are looking for in the gravimetry analysis. Next is always use the analytical balance to weigh the mass changes. Okay, and this method actually still being applied by the industry and environmental research. So here is the types of gravimetric methods. Okay, the first one is precipitation gravimetry. This is a very common gravimetry method, and it does require a signal uh, in a gram unit, which is a mass of precipitate. And basically, the reaction does involve like to determine the chlorion, okay, and basically by precipitate the Ag silver nitrate with the chloride ion to form a silver chloride. Okay, so at the end, the silver chloride will be formed as a precipitate. The second one is electrogravimetry. So this method is actually based on the mass of electrode deposit. Okay, the mass of an electrode deposit on the cathode or anode. Okay, so we can see the difference in mass of the electrode itself. Okay, for example, to determine the lead ion by oxidized to lead oxide and deposited on platinum anode. Okay, so this is just to show that oxidation and reduction occurred. Okay, by implement the electrochemistry information. Okay. The third one is a volatilization gravimetry. So basically, this technique does require the signal such as a loss of a volatile species. So when we talk about volatilization, it means that we are talking about a volatile species. And this shows that the mass will become decreased. Okay, because as we know that when we do a volatilization process, the volatile species will leave the mixture. Okay, so that's we can and then we can determine the mass changes. Okay, for example, to determine water in food contained by heat or thermal or chemical energy. Okay, so last one is the particulate gravimetry. So in this method, it does measure mass of particulate analyte. Okay, by using a certain suppression technique. Okay, like suspended solid. Okay, so here we can see to determine the solid that can be separated from the sample via filtration or extraction. Okay, when we talk about precipitation gravimetry, we're always talking about the solubility of the mixture. Okay, when we can see there are certain colloid or we call as precipitate form in the mixture. Okay, so it does explain about the solubility in water. Okay, so when we talk about the solubility, it means that when the precipitate is formed, okay, so we can assume that the insoluble compounds, okay, will appear. Okay, so here what we can see, the appearance of insoluble compounds in the solution containing our analyte, okay, after the precipitating reagent, or we call as precipitant, is added in the mixture. Okay, so basically in this case, you can see that very clear when you do a titration. Okay, for example, how they can set up for this experiment is that the precipitant or precipitating reagent will be put in the burette. Okay, and your solution will be contained with your sample solution. Okay, so here you can see when the precipitate form and then it will be filtered and washed. Basically, they will wash by using the ionized water. Okay, this is to remove the impurities. Okay, to remove the impurities from the outside. Okay, outside of the precipitate. Okay, next is to convert to a product known composition. Okay, so this is actually we know what is the precipitate. Okay, so after that we will weight the precipitate that form. Okay. Okay, this is the steps in gravimetric analysis. So in such way for you to do gravimetric analysis experiment, okay, the first step is you need to dissolve a sample after weighing. So after you dissolve the sample, then you can do the analysis. Okay, basically the sample sometimes are in solid phase, in solid form, so you need to dissolve it first. Okay, second, a precipitating reagent with excess amount is added to the solution. Okay, so here you can see by the time you add precipitating agent or precipitant, okay, suddenly the colloid, the solution will change. I mean, it will become more thicker, okay, thicker, produce precipitate, okay. Okay, the third one is the resulting precipitate is filtered, dried, or ignited and weak. Okay, so this is what I explained just now about the following step after you do titration, and then the precipitate form. Okay, and after that you will filter this precipitate and you dry it. Okay, so that we can remove the excess solution that still attach on the precipitate. Okay, and after that you weigh the precipitate. Okay, number four, to determine the amount of the original ion from the mass of the precipitate. uh, so here we know that what is the composition. So there is nothing problem with what is the precipitate. So this is what you already know before you do the experiment. Okay? So you can easily determine the amount of the original ion from the mass of the precipitate that you weighed just now. Okay. Okay, so the last one is the stoichiometry. Okay, when we talk about stoichiometry, first of all, you need to know what is the chemical reaction involved. After that, you can simply calculate based on the weight that you you get just now. Okay. Okay. So, what is the ideal precipitate for gravimetric analysis? When we talk about ideal precipitate, we always refer to a very good high quality of precipitate. So the first one is insoluble or low solubility. When we have a precipitate that is insoluble in water, so we can estimate that the precipitate will not go back or will not return to the solution. So the insolubility, or I mean the low solubility precipitate, is a very good properties, okay, to produce an ideal precipitate. Okay, next is easily filterable. Sometimes when we want to filter the precipitate, uh, some of the colloid, what we call is like small, very fine particles, okay, that still are not agglomerate, okay, with the bigger particles, it will passing through the filter paper. So this is where we can see that um, uh, problem might occur when the colloid or the small particles that consist of to form a new precipitate is not easily to filter. So here, what we can see, if they are very good to be agglomerates or accumulate, okay. So uh, so we can see that it is a very good precipitate, okay. So here I want to explain also about the properties. Okay, when you have the large particle size, the smaller total surface area. Okay, when we have this kind of large particle size, okay, so this is actually we can have a very minimized impurities. Okay, so next is pure. Okay, so when we talk about pure, we always refer to a very high purity of precipitate. Okay, so basically we are not it is not easy to get 100% purity. So basically we will get about 99% of purity. Okay. Okay, next is known composition. So when you do an experiment, when you want to do a titration, even though a simple titration, you must know what is the chemicals involved, what is the precipitant, and what is your sample. Okay, because if you don't know this and how you can do the experiment, so you must know what is the composition of your samples and what is the composition of the your precipitant. Okay. Okay, when we talk about precipitating reagents or precipitant, there are two types of precipitating reagents. So the first one is selective, okay, and the second one is specific. Okay, when we talk about the first property, like selective, okay, so for example, silver nitrate is very selective towards uh, halides group, okay, the group 7, okay, the halogen groups, okay. So when you can see that from the chemical reaction that has been showed in the slide, okay, the silver nitrate plus with halides will produce the silver halides, okay, so it will form a precipitate, okay. And other than halides, we also have the CNS uh, negative, okay, so they will also form the precipitate. So the next one is specific, okay. Specific, for example, the glyosine, okay, DMG. This precipitant will only precipitate ion nickel from alkaline solutions. So you can see that the difference between the specific and selective, you can see very clear from these two examples. Okay, so like for the selective properties, it only react with a few analytes. Okay, so when it comes to the specific properties, we are talking about that only that precipitant will react with nickel ion, okay, from the solution. So we can see that that is a very big difference between the selective and specific. Okay, next, when we talk about solubility, okay, so basically we will see and we will refer to a variety of KSP value. What is KSP? KSP is the coefficient constant for solubility product. Okay, so this is what we call as a solubility product constants. Okay, so here we have a variety of salts. Here we have a lead sulfate, silver chloride, okay, silver bromide, and so on. So here you can see this KSP value. Okay, so you can see very clear. This is about 1.6 times 10 to the power of minus 8. Okay, so here is like this is for the mercury sulfide, okay, about 4 times 10 to the power of minus negative 53. Okay, so when we try to consider the solubility properties based on this table, you can see very clear when you have the KSP value very high, it means that it has a very high potential to be soluble. Okay, so when you have a very low KSP value, you can see that it is not easily to be soluble. Okay, so when you have a very small KSP value, it shows that it is not easy to be soluble in water. Okay, so when we talk about solubility, by comparing to the KSP value, you can see the solubility is actually equals to square root of KSP value. So here you can see a different value of solubility according to different salt. So you can see that for the lead sulfate, the solubility is about 1.3 times 10 to the power of minus 4. And by the time you want to compare with mercury sulfide, it is a very big difference, okay, between these two values. So we can see that the solubility in mercury sulfide is very low. compared to lead sulfate. Okay, when we talk about solubility, we always refer how can some chemicals or some salt, certain salt, can soluble in water. Okay? That is the keywords that need to comes into your mind by the time you want to understand the solubility. Okay, so what is the ion that always soluble? Okay, almost. Okay, in almost cases we consider that this is soluble. Okay, for example, nitrates. Okay, acetates, and also group 1. Okay, these are what we call as a neg. Okay, and other than that we have also sulfates, ammonium, and group halogen. Okay, the group 17. Okay, so when we talk about the solubility also, we have the exception like PMS. P is referred to lead ion. M is mercury, and the next one is silver. Okay, so these are three elements. It is not soluble in water. Okay, other than that, we have also the castrol base here. Okay, castrol base is actually referred to the calcium ion, strontium ion, and barium ion. Okay. Okay, when we talk about precipitate, okay, when we talk about precipitate, there are always two types of precipitate that will be formed. The first one is colloidal suspension, okay, and the next one is crystalline suspension. What is the difference between colloidal and crystalline? Okay, you can see the size of the diameter is different. Okay, so you can see the colloidal is actually uh, very small. Okay, very small, and very small compared to crystal. So here you can see that some of the colloid particles will passing through the filter paper. So you need a very small uh, mesh size of the filter paper to filter the colloid suspension. Okay. So here you can see also it is normally remain suspended, okay, and very difficult to filter. Okay, okay, crystal like what you can see sugar, okay, from the salt. Okay, you can see that is another one example. Okay, they show this crystalline properties. Okay, like sugar, salt. Okay, they have this kind of lattice. Okay, so here normally settle out spontaneously, so you can easily filter the precipitate. Okay, now this is the factors that determine the particle size of precipitates. So this part is very important for you to understand very well. So when we talk about the factors, okay, that may influence the particle size. So the first one is precipitate solubility. The second one is temperature. So by the time you increase the temperature, so you will increase the solubility. Uh, Next one is a reactant concentration, and next is the rate at which a reactant mix. Okay, and the last one is the pH. Okay, so when we talk about rate at which reactant mix, we always refer to the time. Okay, so either you you add the precipitating agent very slow or very fast, it will affect the formation of the particle size of precipitates. Okay, so when we talk about the pH, basically it will form large or different size of particles. And for example, the calcium oxalate. Okay, so this kind of crystal uh, is will be can be formed. Okay, uh, at mild acidic pH. Okay, so you can see very large in the pH of acid. Okay, so here, what is the mechanism of precipitate formation? So basically, it will refer to the nucleation. So when we talk about nucleation, it always refer to the the basic component of individual ions, atoms. Okay, so what we call as to form a nuclei. Okay, what is nuclei? Okay, nuclei is something that consists of like a very like a proton and neutrons. Okay, so this is a very important point for you to understand the nucleation. Next is if nucleation predominates, a large number of small particles result. Okay, so when you have a variety number of nucleation, so we can see that the small particles will be formed. Okay. Next is the particle growth. So when we talk about particle growth, we always refer to the um, what we call as like when you do an experiment uh, to, to crystallize sugar solution. Okay, for example, it will form a very beautiful lattice of structure. So this is it. This process will takes a long time. Okay, to produce the particles. Okay, so when if particle growth predominates, a smaller number of large particles will be observed. Okay. So here is the nucleation process, the induced nucleation that we always refer as uh, initiated by seed particles. Okay, so here you can see the spontaneous and induced. So by the time when we have a spontaneous nucleation process, so the very good, a very good precipitate will be formed. And when we have induced nucleation, basically it will consist of impurities such as dust, sometimes glass fragments, and also other crystals that might be trapped in the precipitate. So when we talk about particle growth, the mechanism is very simple, but this process does require a very long time to produce. Okay. So here you can see that from the particle growth, it will form a large filterable particle. So this is a very common method or mechanism in such a way to prepare or to produce a precipitate. Okay. Okay. So this is the explanation or a good example of a precipitation process. Okay. So you can see very clear different charge become a layer. Okay, so you can see that always positive will attract to negative charge and the positive charge will repulse to positive charge. That is very common. So here what you can see from this figure, you can see the electrical double layer is formed. So you can see that um, here the nucleus of silver chloride, okay, as your precipitate, okay, was formed as a colloid. Okay, and after that you can see also the loosely associated counter ion. So you can see like for this nitrate, for this nitrate also is what we call as a loosely associated counter ion. Okay, so why we call it as loosely, because it is very far from the electrical double layer. So there is not a very strong interaction between the double layer, the electrical double layer, and the this nitrate. Okay. Okay, so when we talk about the primary adsorbed silver ion, so you can see that the silver ion attract to the negative charge um, of the precipitate. Okay, so here you can see when you can see this is as the primary adsorb. So this is the first layer. Okay, um, the first layer of the precipitate. Okay, and this is the solution must be homogeneous. That is a very important point in order to produce a very good precipitate. So you need to have a homogeneous solution. Okay, so you can see this is just a boundary of ionic atmosphere. Okay, just to show that it is a the interaction is in between occurred in the ionic atmosphere. Okay, next is so this is just the text that telling you about the formation of silver chloride in just like what I mentioned to you in the previous figure. So in order for the colloidal particles of silver chloride form, they also grow impurity. Sometimes that is not what we call as impurity. It's a loosely ion, counter ion. Okay, that always exists. Okay, by the time silver chloride form. Okay, so here you also can see when the both uh, when both layers of positively charged particles and negatively charged ion atmosphere are known as the electric double layer. Okay, so the attraction between the positive ion and negative ion, it can be something that to produce it can produce produce what we call as electric double layer. Okay. Okay, so when we talk about the previous figure, okay, about the silver chloride formation. So here we can see that the terms that are very important for this process is what we call as adsorption. Okay, so when we talk about adsorption, okay, adsorption is a process where a substance is attached to the surface of a solid. So when we talk about the adsorption, it means that the ion easily attract to the negative charge of the surface. So what we call as the attraction, okay, attraction between different charge of ions. Okay, so it is also different compared to absorption, whereas absorption is a process where substance is held within the pores. Okay, so adsorption occurred on the surface. So it is different with absorption. Absorption, um, it does attract to a pores. Okay. Okay. Next is the electric double layer. A layer of charge absorbed on the particle surface together with a layer of net opposite charge surrounding the particles in the solution. So in this terms, electric double layer, we always refer to the to the particles surface, okay, that will have different kinds of charge on the surface, and it will attract opposite charge from the free solution, okay, to make the precipitate become larger.